Hey guys, so today you and I are going to talk about over-engineered super systems. So let's get into it. So the question in question was, Frederick, can you describe an over-engineered internet scale system that can handle billions of users, multi-region, multi-availability zones, multiple accounts, role-based access, and so on? Well, yeah, I can describe it if you want to know how to set it up. That shouldn't be too difficult, but I'm not really sure where you're going with this. Well, if you were to build a system that is going to handle billions of users by modern standards, unless you're gonna do like an on-prem thing, which I would not recommend because that getting the funding for all your own machines and so forth, well, it also depends on the size of the system, of course, but let's assume it's a standard. I mean, the only systems that have this amount of users is usually some type of mass consumable product that is either a social media network or a website with like shopping or something like that. We're talking about a system that is at the scale of Amazon or Google or something like that. Like their search engine or the shop or something like that. But how to do it is actually not as difficult as you might think. So the first thing that stands out to me is that you need to figure out the pricing for this thing, because the reality is that even if you have billions of users, that doesn't necessarily mean that you're generating billions of requests in traffic. So when you look at the nature of the product, this is where you need to take a look, figure out, all right, because a system of this size usually doesn't come like as a one monolith, unless you've, as I said, like this is a made-up system. But figuring out how to segment your different computation needs is very useful. So an example would be if you were to create a betting website, or if you're going to create a auction thing or sell something like tickets or etc, where you have very spiky traffic, but overall the load is very low during off, non-on sales, like things like that. If peak hours is a thing for you, that is a very different sort of consideration than if you were to have something like, I don't know, Google's search engine, which is bombarded every single second by, like, I don't even know if it must be billions of requests. And so this is the first thing, because the cost is going to be fairly significant for you. But the infrastructure choices are fairly straightforward. Multi-region and multi-zone availability zone is considered standard practice among all the cloud providers, which means that setting that up is actually, I would suggest a system of this would use something like Terraform or some other sort of bootstrapping or infrastructure tool. You don't have to use it, you could manually set it up, but I don't think I need to explain to you how to do this, because you can Google right now for how to do that, and you're gonna find tutorials to do this. Every single cloud provider provide this. And so once you have the infrastructure sort of thought out, what needs you're going to have, my suggestion would be that you default to using Kubernetes. And the simple reason being because a system of this size is very likely to grow fairly significantly over time, and container management is a very nice default. It's a very good starting point, because you can move into other forms. So it gives you flexibility, which is very useful when you have these really large projects where you don't really know what the end is. And this is the reason I recommend that you take a look at Kubernetes if you're going to build something like this. Not, as I said, this is a fictional, guys, it's a fictional system, because a system of this size, you don't sit down and build this at like day one. If you've started doing something like this on day one, you would go through it in a certain natural, it's sort of, we're imagining a person that just jumps in becoming an adult and skipped being a toddler and being a teenager, because usually the way you start these sorts of things is with like a single monolith, something simple, and then you grow into this level of complexity. The journey is still the same, but you might not want to start out on your first day using, say, Kubernetes, because it's a bit of overkill for a smaller system. Multi-account support, that's a straightforward one. If you want someone to have access to more than one account, you basically just need an identity of some sort. Here is where the abstraction is pretty important, where you separate a account from the user, if that makes sense. So it depends on what your preference terminology is. If some call it an identity, because what's nice about an identity is that an identity can, in theory, contain multiple accounts. You can have you can have systems, you can have users, etc., etc. And you can also say that you don't want the identity part. You could say that you can have a abstraction called a account, but then you have users or systems or something like that. The main thing is that you abstract away the fact that an account is tied to a user. The reason being because if you have more than one user account, it's the classic one is that if you say you have you can combine email addresses into one account, or you might have multiple accounts on a platform with different logins and different email. You need some type of unique identifier. The email is usually the thing that you have as the unique identifier for each account, but they can still have the same rights and privileges. They can be merged, if that makes sense. And if you want that, it's important to understand that you need an abstraction layer on top of the fact that you have multiple ways of logging into the system. If you do that, it becomes seamless for the rest of the system, because the worst thing that I've seen happen here is usually that it starts out with having one user, and all of a sudden you can have more than one user, and the system doesn't have a nice abstraction, so it has to go and check multiple users, check if you have more than one user, etc., etc. It becomes a little bit ugly in the code. And as for role-based access, which is sort of interesting, because role-based access, if you're going to build that, my recommendation to you is to model it the same way as the operating systems do, where basically you need to take a look at creating a tree structure of access, where you practically all operating systems work the same way. You have a root account or a systems account for the Windows operating system. That account has super user privileges, basically, where it has access to everything. From that account, you have the possibility of assigning rights to other accounts, and those accounts in turn could access, you can give a admin user certain privileges, but not the same as a system. But the admin can still then give access rights to users and so forth. So if you follow that model, you basically have a blueprint for how to build a very well functioning, completely, I would say it should be your default if you're ever doing role-based access. It's the model that is probably the most established model for all role-based access systems. So what I want you to take away from this is that if you wanted to create a system that can handle billions of users, it's actually not a big problem by today's standards. What it comes down to is, do you have what cloud provider do you want to use, because they will provide you with what you need. The really challenging part with a system this scale is usually how to grow it at the development level. How do you actually do development on this thing, and can you handle the overall traffic? That's less of an issue if you don't have very spiky traffic. A classic problem is that you allocate way too many boxes, and then your money dries up because you can't pay the cost of all the virtual machines that you're using, and then it goes down anyway because the spikes are the problem, where during certain peak hours the load is so high that the system starts going down. And the finances of this is usually the thing that is most important to get right when the system is this large. And then apart from that, multi-availability zones and regions and so forth, these are standard features on every single cloud provider. When you're dealing with more than one account, I very highly recommend that you always think in terms of one level of abstraction, which is usually called an identity or account or something like that. And that account can have more than one user or more than one service, depending on if you have a service account or if you have a user account, etc., etc. Because when you abstract away the identity, you just have an abstraction that tells you this is proof that I am part of this account or this user's identity. Then you can have as many accounts usually as you want. Role-based access, just model it after the operating system. That's a very good starting point. Then we can talk about more complicated situations where role-based access might not actually by today's standards be enough. It's not for Europe with GDPR laws and so forth, but I mean, I've already talked for like 10 minutes now, so I can't go into all of the role-based access considerations, but if you start with the operating system's way of doing it, that should be a very good and solid point to begin at. Have a great day.